All right, so today we're going to be doing the clouds and dew point lab. So, you may have noticed that on some days the clouds appear to have a low altitude. Other days the clouds seem to be a lot higher up. And some days it was foggy outside. What that means is you're actually walking in a cloud. So fog is a cloud that's just at ground level. Now, the reason why you have clouds at different elevations or different altitudes has to do with the air temperature and the dew point temperature. All right? Because for a cloud to form, condensation has to take place. So if there's fog, what that basically means, going back to station models, is that your air temperature and your dew point temperature must be the same, and as a result, the air is saturated, your relative humidity is 100%, and the condensation is taking place, because condensation is what makes the clouds or makes the fog. All right? But let's say the air temperature and dew point are different temperatures, like they are over here. Right? If your air temperature and dew point temperature are closer together, that means the cloud is going to be a lower altitude. If your air temperature and dew point temperature are farther apart, that means the clouds are going to form at a higher altitude. Right? And the reason for that is for the cloud to form, for the condensation to take place to make those clouds, the air has to cool down to the dew point temperature. Now, as air rises, the higher up it goes, the cooler it gets. And the reason why air cools down as it rises is because the higher up you go, the less air pressure there is. And the less air pressure there is on a mass of air, the air expands, right? Because there's less pressure when you get higher up, it's going to get bigger and bigger and bigger. As the air expands, that causes it to cool down. All right, it's called adiabatic cooling. All right, so as the air cools down, as it's rising, eventually it's going to reach that dew point temperature and clouds form. So if there's only a small difference in temperature between the two, then the air only has to go up a short distance before it reaches the dew point temperature. If there's a big difference in temperature, that means the air has to rise up a lot higher before it cools down to the dew point temperature and they get condensation. Now, a little glitch in this though is that, so as you go up in elevation, the air temperature cools down. But what also happens is the higher up you go in elevation, the dew point temperature goes down too. So both temperatures are going down, but they're going down at different rates. The air temperature cools down at a faster rate than the dew point temperature is. So eventually there's going to be a point where those two temperatures are the same, and that's when condensation is going to happen. All right. So with the lab, I'm going to read the intro out here, and then I'll show you how to use a chart to figure out cloud elevation. All right, so it says, a cloud is a visible mass of liquid droplets or frozen crystals made of water suspended in the atmosphere above the surface of the earth. Clouds form when air containing invisible water vapor rises and cools to its dew point temperature, the temperature at which air becomes saturated. Saturated means the air is filled with water. All right, you can't hold it anymore. The main mechanism behind the process is adiabatic cooling. Atmospheric pressure decreases with altitude, so the rising air expands in a process that expends energy and causes the air to cool, which reduces its capacity to hold water vapor. If the air is cooled to its dew point and becomes saturated, excess water condenses in the clouds. The altitude at which this begins to happen is called the lifted condensation level, which is roughly determines the height of the cloud base. Water vapor or saturated air is normally attracted to condensation nuclei, such as salt or dust particles that are small enough to be held aloft by normal circulation of air. If the condensation process occurs below the freezing level in the troposphere, the nuclei help transform the vapor into very small water droplets. Clouds that form just above the freezing level are composed mostly of supercooled liquid droplets, while those that condense out at higher altitudes where the air is much colder generally take the form of ice crystals. In absence of sufficient condensation, particles at and above the condensation level causes the rising air to become supersaturated, and the formation of clouds tend to be inhibited. All right. So what do you got to do? All right, so on this chart here, what this shows you, here's the temperature and here's the altitude. And it has a bunch of solid lines and a bunch of dashed lines. The solid lines represent how much the air temperature is changing. The dashed lines represents how much the dew point temperature is changing. So for example, 40 degrees Celsius air right there. If I had air that was 40 degrees Celsius and it went up to 1 kilometer in altitude, right, the temperature of that air would then be 30 degrees Celsius. Okay? Whereas, let's say I had air, the dashed lines represent dew point. If I had air with a dew point of 20, I'd follow up the dashed lines for dew point. I'd go up to like right there. The dew point temperature would only drop about 2 degrees going up a kilometer, roughly. All right. So over here, what you're going to try to do is you're going to want to figure out what the cloud base is. In other words, what altitude clouds form based on this air temperature and dew point temperature. All right, so first one I did for you already. Air temperature 30, dew point temperature of 8. There's a 22 degree difference. All right, so how you go about doing this is you find the 30 line, you find the 8 line, you follow the 30 line up the solid line, you follow the 8 line up the dotted line, like that, and eventually there's going to be a spot where those 2 lines cross, which is right about up there, so about 2.8 kilometers. All right. Now, it's kind of hard to keep track of those lines when you're doing it that way. So I'll show you a little hint to make this easier. All right. I'll do the second one for you. Or air temperature 30, dew point temperature 14. All right. So I subtract those two, I get 22 degrees. Or, I get 16 degree difference. To make it a little bit easier to follow the lines, what you can do is take a piece of scrap paper and go to the 30 and have a piece of scrap paper follow up that line. So there's my edge of my paper, like that. All right, so where the edge of the paper is, that's the 30 line. So now, my dew point temperature is 14. So there's 14. I'm going to follow up the dotted line like that. And then right there is where it hits the 30 line. So right there, the altitude would be 2 kilometers. Okay. So my air temperature is 30 and my dew point temperature was 14. My cloud base, my clouds will start forming at 2 kilometers up. Okay. All right, so you're going to do that for the rest of this page, so that should be fairly simple. All right, next page of the lab. All right, so this page, next page of the lab, part 2, says fill in the data table below and graph the data on the grid to the right of the table. As air rises, the air temperature or dry bulb temperature decreases by 1 degree for every 100 meters. Start with 19 degrees at the surface and subtract 1 degree as you fill in the air temperatures in the table below. All right, so at the surface, the air temperature is 19 degrees. When I went to 100 meters up, it drops to 18. At 200 meters up, it drops to 17. 300 meters, 16, and so forth. So you can do the rest of that on your own. All right. Next, it says, as air rises, the dew point temperature decreases by 0.17 degrees Celsius for every 100 meters. Start with 10 degrees at the surface and subtract 0.17 as you fill in the values for dew point in the table below. All right, so we start off at 10, and what I'm going to do is I'm going to minus 0.17, that gives me 9.83. I'm going to minus 0.17, that's going to make this 9.66. When I take that and I minus 0.17, it's going to make that 9.49. And then I just keep going up all the way up. All right, next, you're going to take this data and you're going to graph it over here. All right. So for my temperature data, it says now create a graph on the grid to the right table. The x-axis is temperature. Start with 0 and go by 2s. So this is going to be 0, 2, 4, and so forth. It says the y-axis is height. Start with the surface, which is 0 meters, and go up by 100 until you get to 1200. So there's 0, that'll be 100, 200, and so forth. Label the y-axis height in meters. Meters. So you're going to graph all this data and make a line, graph all this data and make a line, and when you do that, there's going to be a point where those two lines cross, and the spot where those two lines cross, you come over here, and that's going to be what the altitude of the cloud is, all right? So that's what you do on that part of the lab. And then the answer to the question is based on that. Third part of the lab. Third part of the lab. All right, so it says, using a sling psychrometer to measure the air's current dry bulb and wet bulb temperatures, use those temperatures in the chart from your Earth Science reference tables to determine the air's current dew point temperature and relative humidity. All right. So a sling psychrometer is this thing right here, where it had a regular thermometer, then it has one with a little sock on it. What I'm going to do is I'm going to get that little sock wet, and then I'm going to start slinging it around. So I start slinging it around like this. Sling it for like 20 seconds or so. So my dry bulb temperature looks to be about 20. And my wet bulb temperature looks to be about 16. So all right, 20 and 16. All right, now to find the dew point temperature and relative humidity, what you have to use, you should already know how to do that. You have to use the chart from your reference table. So use that chart, look up the dry bulb, and then the difference between the wet bulb and dry bulb there. That'll give you the dew point. And here you look at the relative humidity, dry bulb, difference between wet bulb and dry bulb to find the relative humidity there. All right. Then the last step is you want to find out what the cloud-based altitude is right now. All right. So based on these numbers that I just recorded from the current conditions in this room, I want to figure out what the cloud-based altitude is. So using my air temperature and the dew point temperature that you're going to find out in a little while. All right. I'm going to go back to this chart here and look up the dry bulb and the dew point, and then follow the dry bulb temperature line, the dew point line, and then wherever they crisscross up here, that's going to be the altitude of the clouds in kilometers. And that is how you can use a sling psychrometer to figure out how high the clouds are. Okay? So that is and then there's questions on the next page of this to answer to. So that is the lab.